All right, so we're going to spend 2 days looking at 6.5, and this is going to be about finding the average value of a function. And this is going to be our last lesson in Chapter 6. We're not going to have a Chapter 6 test because we're just spending a week on this. 2 weeks on this if you include the 2 days previously, but you will have a quiz on Friday of this week, the 23rd, which will cover everything in Chapter 6, 6.1, 6.2, and 6.5. So just giving you that heads up. Now let's get ourselves ready for notes, and we're going to get started finding the average value of a function. Now, in order to find the average value of a function, we take our function here in terms of the graph, and you think about the average as the sum divided by the number of objects you're counting. In this case, you're counting all these infinite little sets here, which we can think of as just the interval from A to B. So the average value is the integral over B minus A. And it's usually written as 1 over B minus A times the integral like this, just because we're more used to seeing things written like that instead of a fraction holding the integral. So the average value is 1 over B minus A times the integral from A to B of the function, and that'll give you the average value that it has. So here the average value would be C, some above, some below, and the average value is right there. So let's use this formula. Find the average value of f of x is equal to x squared times root x to the third plus 1 between x equals 0 and x equals 2. So we're going to start with the intervals. So we've got A and B right here. And so we're going to plug that into our formula. 1 over 2 minus 0 times the integral from 2 to 0 of f of x. So x squared times root x cubed plus 1 dx. So what we can do quickly is we can simplify this fraction to just 1/2, and then we need to figure out how to evaluate this integral. And what I'm going to notice here is that I have a product with a polynomial on the inside and one less on the outside. So what I'm going to do is use substitution. I'm going to say u is equal to, as always, the inner function. So then du dx is equal to 3x squared. Now I have x squared dx, so I'm going to solve for that, and I'm going to multiply my dx over, so du is equal to 3x squared dx, and so then 1/3 du is equal to x squared dx. So I will do my substitution for my integral, which would be root u, for right here's our root u, and then x squared dx, 1/3 du, 1/2 multiplied on the outside to find the average value. Now, because it's a definite integral, I'm going to plug in my bounds. So I'm going to have the new bounds being 2 cubed plus 1 and 0 cubed plus 1, plugging in the formula there. So I get 8 plus 1, which is 9, 0 plus 1, which is 1. So my new bounds are from 1 to 9, which is nice because I'm plugging them into a root. I'm going to bring the 1/3 out since it's just a coefficient. So then I get 1/6 integral from 1 to 9, and I might write this as a power so I can use the anti-power rule. So I end up with 1/6 times u plus 1, u to the 1/2 plus 1, so u to the 3 over 2 over 3 over 2 from 1 to 9. Simplifying, dividing by 3 over 2 is the same as multiplying by 2 over 3. Cancel, cancel 3, so I end up with 1 over 9 u root u as a simplifying of u to the 3/2 from 1 to 9. So 1/9 times 9 root 9 minus 1/9 times 1 root 1 is 3 minus 1/9, which is equal to 26/9. So that would be the average value of this function between 0 and 2. Now you can also use it for word problems. The population of rabbits is modeled by the function P of t is equal to 250 e to the 0.12 t, where t is measured in years. What is the average population of the rabbit's first 10 years? So first 10 years, so first means that a is equal to 0, and 10 would be our upper bound. And so then the average value is going to be 1 over 10 minus 0 of the integral from 0 to 10 of the population, like so. So that becomes 1/10 times the integral of 0 to 10 of 250 e to the 0.12 t dt. Once again, I would use u substitution because I've got the coefficient there. So then du dt is equal to 0.12. Can multiply the dt up and divide that over. So then I have the integral 1/10 times the integral of 0 to 1.2, because I'm changing the bounds by multiplying 0 and 10 by 0.12. 250 e to the u times 1 over 0.12 du. Now I've got a lot of simplifying here with coefficients. I'm going to say that this becomes 25 over 0.12 times the integral of 0 to 1.2 e to the u du. As we know, the integral of any e to the u is just itself. So 25 over 0.12 e to the u from 0 to 1.2, which gives us 25 over 0.12 e to the 1.2 minus e to the 0, which is just 1. And at this point, I can either leave it like this, or probably going to make the most sense to plug into a calculator, and I get 483. It's a word problem, so the average population is rabbits, since that's what the population function is measuring. If you have questions about average value or anything in Chapter 6, please don't hesitate to set up a Zoom meeting or reach out in the comments or by email. Talk to you later.